In this video, we're going to talk about linear inequalities. So inequalities meaning not equalities, but with less than or equal, or less than, or greater than or equal, etc. Specifically focusing on how to graph the solutions. Okay, but before we do that, we want to just note, okay, inequalities behave similarly to equations with equalities. So below are some basic properties of how you can work with them. But be careful because there's one exception. Okay, so one way in which they are different from equalities. So if you know that A is less than B, then if you add C to both sides, you know that A plus C is still less than B plus C. Okay, so if A is smaller than B and you add the same number to both sides, it doesn't do anything. Or if you subtract the same number to both sides, doesn't affect the inequality. So if you add or subtract the same number on both sides, just like with an equation, okay, the inequality stays the same. Now, if you know that A is less than B and you multiply by C on both sides, and here you're multiplying by a positive number, okay, then the inequality stays the same. Okay, so A times C is going to be less than B times C. So here's where the difference occurs. If you multiply, or divide for that matter, because it's like multiplying by 1 over the number, and your number that you're multiplying by is negative, okay, what's going to happen is you're going to flip the inequality. Okay, so if you multiply or divide by a negative number, okay, the inequality flips. Okay, so we won't be needing to really manipulate inequalities that much, but it could be that you want to if you prefer to graph using, say, slope-intercept form. Then you might be manipulating them a little bit, so you want to be careful that they act just like equalities, except if you multiply by a negative number or divide by a negative number. Now, I wrote all of these rules with less than, okay, but they're true for all of them. Okay, so less than or equal, greater than or equal, greater than or less than. Okay, it doesn't matter. Now, just so you maybe know, so note. So A less than or equal to B means that A is smaller or equal to B. So the way that you can remember this, and the way that I was taught, is if you turn this into a Pac-Man, okay, Pac-Man eats the bigger one. Because he likes to eat more than not less. So the one that it opens to is always the bigger one. Okay, so no matter which one you're using. So that's a way you can sort of remember that. So how do we know if a point is a solution to an inequality? Well, when we had equality, so lines, we just plugged in the point. Okay, we're going to do the exact same thing here. So I'm going to plug in these 3 points into this inequality, sorry. So the point 0, 0. I'm going to have 0 is bigger than or equal to negative 1/2 times 0 plus 3. So if I simplify, that means 0 is bigger than or equal to 0 plus 3, which means that 0 is bigger than or equal to 3. Okay, this is not true. Okay, 0 is strictly less than 3. So what that means is that 0, 0 is not a solution to the inequality. So remember, if you get something that doesn't make sense, that means that the thing you plugged in was not a solution. Okay, if we plug in 2, 2, then I'm going to have 2 is bigger than or equal to negative 1/2 times 2 plus 3. So this says 2 is bigger than or equal to negative 1 plus 3, which means 2 is bigger than or equal to 2. So now because of the equality, okay, so this inequality includes equality, so that means that this is a true statement. So that means that 2, 2, the point, is a solution. Okay, in fact, 2, 2 is on the line. If we replaced the inequality with equality here, 0.22 would be on that line. Okay, one more. so the point 4, 5. So if we plug that in, it says 5 is bigger than or equal to -1/2 times 4 plus 3, which says that 5 is bigger than or equal to -2 plus 3. So 5 is bigger than or equal to 1. Okay, this is also true because 5 is bigger than 1. So the point 4, 5 is also a solution to this. Okay, now solutions of these linear equations can be represented by a line in the xy plane. How does this affect when we have an inequality? So because I used one that includes the equality, all the points that are on the line, so like 2, 2, are going to be on the graph if we tried to graph the inequality. So what we can do, maybe I'll just write that. So all points on y equals -1/2 x plus 3 are solutions because they're of the equality. So we can start by graphing these. Okay, so that means that the y-intercept is 3 and the slope is -1/2, so I go down 1 over 2 to get another point, or up 1 over 2 the other way. Okay, so this is the line y equals -1/2 x plus 3. Okay, those are solutions. Now, if we just plot our points, okay, remember 0, 0? That's over here. Okay, this was not a solution. Okay, and our point 4, 3, 4, 1, 2, 3, 4, 5. Our point 4, 5, what is a solution? So it turns out that the line, okay, so this line here, that where the inequality is equal, splits the plane into 2 halves. Okay, so you have above the line or below the line here. And it turns out that on one side are all the solutions, and on the other side are all the non-solutions. So in fact, our solution set for this inequality is everything above this line. Okay, so this is what we call the solution side. So when we're graphing this inequality, we would graph the line and everything, and we shade everything above the line here, because that's where the solutions are. Now that I've said that, in fact, I'm going to change this, sorry. So it actually, for our purposes, is better to shade the opposite side. Okay, so I think that's the point 4, 5. Okay, is a solution. Okay, so it turns out that, like I said, this is the solution side. So what we do is we get rid of everything that's not a solution. Okay, so this, we would want to shade all of this side because it is not a solution. So everything that's not shaded is the solution. Okay, so that's the idea. So to graph an inequality, what you do is you graph the equation with an equality. Okay, so i.e. graph the line, because we're only talking about linear inequalities, so it's going to be a line. And we want to use a dotted line if the inequality does not include equality. Okay, so that's when you have bigger than or less than, strictly, with no equality. Okay, so we graph the line, so we know how to do that already. And then what we're going to do is pick a test point. That is not on the line. So you want to be careful that you don't accidentally pick something that's on the line. Okay, so you pick a test point that's not on the line and plug it in the inequality. Okay, if it is a solution, then it's on the solution side. So that means that we're going to shade the other side. Okay, if it is not a solution, then it is on the wrong side. So we shade that side. Okay, so that's how we test. So basically you just want to graph a line. So that's what we did in the previous videos. And then you want to pick a point not on the line and see if the solution is that side or the other side. Okay, and we're going to shade this side that does not have the solutions. So let's just do a couple of examples. Okay, so 2x is less than 6. So we could rewrite this if you want. Or, well, okay, so our first step is graph 2x equals 6. Okay, this is the same as the equation x equals 3. Now we're going to graph, we're going to use a dotted line because we don't have equality here. So the x equals 3 is a vertical line. Okay, at x when x is 3. Okay, so that's the vertical line. That line is going to divide our xy plane into to the left of the line and to the right of the line. So we just want to test a point. Oops. Okay, so that's step 1. And then step 2 is test a point. You can pick whatever point you want as long as it's not on this line. Okay, now I'm going to pick 0, 0. So the origin, because it's easy to plug in and I know for sure it's not on the line because it's over here. So 2 times 0 less than 6. So that means that 0 is less than 6. Okay, so this is true. So that means that the side with the point 0, 0 is the solution side. So what I'm going to do is shade the other side. Okay, so this side is not a solution. Okay, let's try another one. So we first want to graph 4x plus 2y equals 12. So you could turn this into slope-intercept form, or we can just find 2 points. Okay, so when x is 0, I have 2y equals 12, which means that y is 6. So we have the point 0, 6. And when y equals 0, I get 4x equals 12, which is the same as x equals 3. So I get the point 3, 0. Okay, so I'm going to plot those. So 3, 0 is over here. 0, 6 is up here. Okay, now I'm going to graph it with a filled-in line because I'm including equality here. Okay, so this is the line 4x plus 2y equals 12. Okay, now my step 2 is test a point. So again, I'm going to test 0, 0 because again, I know that this point is definitely not on the line. and it's easy to plug in. So I'm going to have 4 times 0 plus 2 times 0 bigger than or equal to 12. So that says 0 plus 0 is bigger than or equal to 12. So 0 is bigger than or equal to 12. Okay, this one is false. So that means that I want to shade the side that has 0, 0. Okay, so this side is not the solutions. Okay, so the other side is where the solutions are. Okay, it might seem weird that we're shading the side where the solutions are not, but when we get into the next video and we're looking at multiple inequalities at the same time, it actually makes things easier. Okay, so that's where we're going.